So in this lesson, we're going to be talking about images in convex mirrors. So in the last lesson, we looked at how to locate images in concave mirrors, but in this case, we're going to look at those mirrors that curve outward. Now, I just want to remind you again that a convex mirror, we can tell what it looks like and that it's not a concave mirror based on the location of these little dashed lines. So remember, the dashed lines indicate the location behind the mirror. And so over here on the right, this would be in front of the mirrors. And so any light rays would be striking the mirror from this side and then bouncing off in one way or another. So just as a concave mirror is referred to as a converging mirror because the light rays come together, a convex mirror, here's the convex surface, is referred to as a diverging mirror because the light rays diverge means move apart. The mirror is going to cause those incident light rays to move apart from each other. So we can see here's a reflected ray, here is a reflected ray, reflected ray, reflected ray, reflected ray. All of those light rays are going to diverge or move increasingly further apart from each other as they continue to, if we extended those and saw where they reflected. Okay, so they're never going to come together on the real side of the mirror. Now, if we look at extending those to create a virtual line behind the mirror, we can see that those virtual lines are going to be what we're going to trace back to locate an image. So that is what we're going to look at today. Now, I think you're going to find that with convex mirrors, the rules are very similar to what we see with concave mirrors, and the outcomes are actually much simpler. So before we move on, there are a couple of things I want you to take a look at and note that are different with a convex mirror in comparison to the concave mirror. So pause the video and think about what is the same and what is different in a convex mirror versus a concave mirror. So what I'm hoping you noticed was the same was that there is a principal axis, right? And that principal axis seems to be sort of in line with the vertex of the mirror right here. So that is similar. What I'm hoping you noticed was different than in the case of a convex mirror. The focus is actually behind or inside the mirror, right? As is the center of curvature, right? And so that's different because in a concave mirror, they were on the other side of the mirror, on the real side of the mirror, as opposed to the virtual side, right? And so that's important because remember, the focus is the point on the mirror where we see light rays converge or come together. And that's never going to happen on the real side of a convex mirror because the light rays are going to diverge. So the only place that makes sense for the focus to be for where light rays can converge is on this virtual side behind the mirror. Okay, hopefully you noted that. If you didn't, maybe that clarifies that for you. Let's take a look at some rules for these light rays. Okay, so let's get started with drawing these light rays. So as I mentioned earlier, we're going to see that the rules for convex mirrors are pretty similar to those of a concave mirror. It's just that the outcome is a little bit different because, of course, the light rays are going to be diverging. So let's look at the first rule. We'll get that down, and then we'll take a look at what is going on here. Okay, so the first rule states that a light ray that is we mean projected parallel to the principal axis, which I've got as a short form here, PA, is reflected as if it had come through the focus. What does that mean? Okay, let's look at a picture. Okay, here's a nice diagram of this. So just to kind of locate you, here's our convex mirror. And this is this is in front of the mirror, and here we have our focus and our center of curvature behind the mirror. And I'm going to project a light ray towards this curved mirror, but parallel to the principal axis. And it's going to reflect as though it's in line with the focus. So if we were drawing this, what I would do is I would draw in this line, and then I would go and draw the line through the focus. But remember, behind the mirror, we always draw those virtual dotted lines. and then I would extend that dotted line sort of backwards and out. And we can see that that's going to cause a divergent real ray. So there's our first rule. So here's our second rule. A light ray through the center of curvature, in other words, aimed at the center of curvature, is going to reflect back on itself. So here, if we look at this blue line, we can see that the blue line is aimed at, if I had a ruler, I would be aiming it so that that line goes completely through the center of curvature, right? So that is my incident ray, right? And so my incident ray I can see because the arrow is pointing towards the mirror. Okay, so I would just locate it. Anything that is virtual, I would be putting as that dotted line again because it's behind the mirror. But then the light ray just goes right back on itself. So hence I can see that reflected ray because the arrow is pointing backwards. Okay, so a light ray through the center of curvature reflects back on itself. There's rule number 2. One more rule to go. Okay, so let's look at rule number 3, our final rule. So this is going to look very similar to what rule number 1 looked like, but there's some subtle differences. Okay, so a light ray aimed at the focus will reflect parallel to the principal axis. So it's almost like rule number 1, but in reverse. Okay, so if we were to aim an incident ray towards that focus, so I've got my ruler and I'm aiming a light ray anywhere on the surface of this mirror, but I'm aiming it towards the focus, it's going to reflect back parallel, right? But remember, it's the reflected rays that we trace back, not the incident rays. So that's why this parallel line that reflects back, it is the one that we're tracing back with that dotted line sort of behind the mirror, okay? And so that's our third rule. We're going to locate the image where these divergent rays all kind of come back to a single point and meet, right? Where they converge. That's where our image point is going to be located in the same way that we saw that with our concave mirrors. So I'm just going to take a minute to look at all 3 of these rules sort of together, and then we're going to look at some more characteristics of the image. So here again is our just comparing and contrasting our 3 image rules. I wanted specifically to compare and contrast the light rays for rule 1 and rule 3. Take a look at, rule 1, we're looking at the incident ray parallel, and then the reflected ray is in line with the focus. So remember, it's the tracebacks of the reflected ray that we put behind the mirror. And here we look at the incident ray being aimed at the focus, but then reflecting parallel. And so it's the reflected ray again that we're going to trace back. Okay, so just notice the 2 differences there between those rules. And so here we have this is a timed interactive. I don't have forever here, but I wanted to show you. Take a look at this. When I move the image, and here's my object, I should say. When I move my object in front of the mirror, notice a couple things about its characteristics here. First of all, I can see, it's not going to let me, but that's okay. I can still talk about it. Notice that no matter where I move this this object, the image is always sort of inside or behind the mirror, right? Notice that the light rays, no matter what, the real light rays are always going to reflect and diverge, so that the image point is always going to be formed by those virtual light rays. Okay? And notice that no matter where, when I was able to, let me see if I can refresh this. Notice that no matter where I move my object, my image is never going to be as big as my object. It's always going to be smaller. My image is always going to be smaller than my object. Okay, so you can also see here's our light ray rule number 2, passing through the center of curvature, reflecting back on itself. Here's our light ray that is parallel but reflects in line with our focus. To create an image point, we only need to have 2 of the rules applied, and then that third one is there to help us out. Okay, so now we're going to think about SALT here for a second. So size of my image is always going to be smaller than my object. Okay, attitude, notice that no matter where I place this image, my attitude is upright compared to the image, or to the object, right? My image is upright compared to my object, right? It's always flipped on this, it has the same directionality to it. Okay, location, where is it? Well, it's always going to be behind the mirror, right? So it's always going to be behind the mirror. We're not going to worry about where it is. And it's always going to be virtual because it's formed by those sort of dotted virtual rays that converge behind the mirror, right? They never converge in front of the mirror. Okay, so let's go back to our note and finish this up and write some, jot some things down. And so I can't move this object around, but we were able to see that in the simulation. This is just to summarize some of those image characteristics in that convex mirror. Okay, we can see here when we look at two of those rules kind of together, they converge to an image point here behind the mirror. Right, here's our light ray. Our incident ray that is parallel to the principal axis is going to be drawn in line with that focus. Here we see this incident ray that is pointed towards the focus that is going to reflect back parallel. And when we kind of do those trace backs, we can see where they converge. Those two lines converge, forms that image point, the top of the candle of that flame there. So when we look at salt, for a convex mirror, it's pretty straightforward, right? We're going to see our image is always smaller, always upright compared to the object, always sort of behind the mirror or inside the mirror on the other side of the mirror, and always virtual. Okay, so hopefully those rules made sense. Again, if you need any clarification, feel free to drop into our Zoom meeting and I can definitely clear things up for you. We can look at a Jamboard and do some diagrams to help you make sense of it. So that's it for today. Take a look at our week plan for some ideas about what work needs to be completed for the day, and we'll talk tomorrow at tomorrow's live session.